or you can go down and to the left. Okay. So if knowing which direction to go on your slope, hopefully that might be something you can use. Remember, you always go up and down first, and then you're going to do rise. So rise over run. The top number is the rise, bottom number is the run. So when the number is just -3, remember that's -3 over 1. So it's negative, you're up 3 over 1 or down 3 to the right. Help a little bit? Okay, you see how we have a starting point? That's like our y-intercept is our starting point. So here on this one, this was my starting point. My slope was -3 over 1. Is that okay? You know where to find the slope. Okay. So that means from your starting point, you're going up 3 and over 1. Up 3 and over 1. Follow it from that point. You're going up and to the left. Or you're going down. You can go down 3 to the right one, because my slope is 3 over 1. -3 over 1. Then that gives you the other points, now you can draw your line.
Do we write, like, we only write no solution, like, we only write a solution with no solution?
Correct. Why don't you write all the ordered pairs that you just shaded? Or let's go for this one. Write all the answers that you shaded in there. It would take you the rest of your life. Okay. So if you think I assigned a lot of homework, at least I could have you do that. That's why we use shading to represent all the solutions instead of writing them all out. Sound good?
Yeah.
Okay, let's jump down to 5 and 6. Those are pretty similar. Find the coordinates of the vertices of the triangle formed by each system of inequalities. What you're looking at here is your graph should have some sort of triangle, like this one on page 148. So when we're done, we should have a triangle, and they're looking for the vertices. The vertices are the corners. They're looking for the ordered pairs that make up that bounded region. This is going to be a bounded region. So when you graph these, they should end up being a triangle of some sort. Okay, you're going to close in that region. So for this, you basically have to graph each one of these three. Those are 3 sides of a triangle. On the bottom one, what will you have to do with that? So solve for y. You have to solve for y. Okay. So we're going to have one. Bottom one is the one we have to solve for y. So the first thing to move over would be the, right. Can I simplify that with the 8? No. No, there's no x with the 8. Good job. There's no x with the 8. 4 has an x, 8 still pure. No x's. So 3y is greater than or equal to -4x plus 8, or you could write it 8 minus 4x. That's okay. One more step. Divide by what? Divide by 3. Just the 4 or just the 8? Good. And then we all hear a groan because like, 3 doesn't go into any of those. So y is greater than or equal to, we're going to leave it negative 4/3 x plus 8/3. Slope you usually want to put as an improper fraction. That's easier to graph as an improper fraction. The y-intercept is easier to graph as a mixed number. So that'd be 2 and 2/3. So that's kind of a hint to help you get both of those on the graph correctly. Slope you want to leave improper. Y-intercept you want to put into a mixed number. If I told you what's easier for you to understand, put a point at 8/3 on the graph, or put a point at 2 and 2/3.
Yeah, let's do 2/3.
Which one is easier for you to know where it would be 8/3 or would it be 2 and 2/3? I know they're the same thing, but well, it's a slope. It's not. I'm not looking for a slope. I'm looking for a y-intercept. So 2 and 2/3 would be between 2 and 3. So 2 and 2/3 tells you, hey, I have to be between 2 and 3. So I'm going to do this one first since we've been working with it. 2 and 2/3 would be a little bit past 2.5. Now my slope is negative 4/3. So on the u, am I using the left side or the right side? Left. Here's my y-intercept. So this starting point is my y-intercept. So how many do I go up? 4. How many do I go to the left? 3. So I can go up 4 and over 3, or I could go down 4 again over 3. Okay, so up and down is always the same number. So from here, now when I go up 4, I have to stay about the same spot. So when I go up 4, I'm going 1, 2, 3, 4. Notice I'm not on the lines. I'm still at that 2/3 mark. If you put it on the line, your line's going to be off. And we want to find the vertices of this triangle that we're going to form, so it's going to be important that we stay on the line. Or stay on that 2/3 mark. And this is solid. Okay, keep going with the first two. The preliminary shading sometimes isn't as necessary here because you know it's going to form a triangle. Pick out the word problems. You're welcome. Getting the rest of the graphs, is that okay? So the final thing you have to do with these, you do have to list these vertices. So it looks like some of these aren't exactly on numbers, so we're going to estimate where they're at. So when I look at this one down here, what would you estimate that to be at? Maybe a half?
Yeah.
Half and then up 2. So one of the ordered pairs would be 1/2, 2. So this is where it's important that you use a straight edge, that you're making straight lines, because if you're off a little bit, it's going to throw these corners off. Is my map agreeing with yours? Okay. So this one up here, maybe 1, 2, 3, 3.5, 8. Looks like 2/3. It does look a little bit past. Does it look a little bit past a half?
No.
On your graphs as well?
Yeah, it looks like my graph is like.
Okay. If you put something between 3.5 and 4, that would be fine. Because I know it's going to be tough to be perfect. I would guess 3.5 just based off what I see here, but it'll be right. And this one looks to be spot on. 2, 3, 4, -4, 8. On Thursday, we're going to have this same setup, and then we have stuff to do with these. They're called optimization problems. They're actually the business problems, the business sort of things. So you create a system of linear inequalities that you're trying to optimize your profit, or you're trying to minimize cost, or something like that. And those occur at these vertices. So then you have a function you plug these into, and you figure out what's the highest, what's the lowest, stuff like that. This is a good prequel into what we'll be doing Thursday. Want to do another one, or go for it? Go for it. Go for it and ask me questions if you get stuck, okay?
Wait,
so
with the triangle they always change the type of triangle?
Yep. Yep.
We probably